Okay, so today we're doing section 1.5. And actually, one of the examples today, we're actually going to do some math with actual numbers. Isn't that exciting? It's something you couldn't wait for, I'm sure. All right. But we got a little bit of definition and stuff like that to do, just like we've been doing all year so far. And pretty much the rest of the year, we'll be doing a lot of definitions, postulates, theorems, just learning new stuff. And then eventually, most of the stuff that we're going to be doing eventually is you take a theorem, you take a postulate, and then they might give you an angle, they might give you line segments, and you got to figure out like how many degrees is this angle and how long is this line segment. You have to do a little math, okay? You have to do a little algebra. So we will be doing a lot of algebra in here, mainly Algebra 1 stuff, nothing super hard as far as the math is concerned, all right? But the thing about geometry is you have to put the equations together by the picture, all right? So if this thing's equal to this, you set them equal to each other, then you solve for x, all right? So that's the big difference on geometry compared to Algebra 1. Algebra 1, they just give you the problem. Here, we got to figure out what the problem is from the picture that they give us, and then you can go ahead and solve the problem, all right? You'll see what I'm talking about if that didn't make any sense to you. Let's talk about this. So if I have that, put an arrow at both ends. You probably did this in pre-algebra, Algebra 1. And, yeah, let's just do this. And let me see what kind of example they give for that. Yeah, let's just do this. Let's say you had a number line. We'll just do this. 1, 2, -1, -2. Everybody see this? Kyle, can you turn one of those lights off, the one that makes this a little darker? I forget which one. Yeah, that's good. All right, so we have a number line. You've done stuff with that, right? Ever since you were younger, a few years ago. All right, you did number line stuff. But I want to give you a word. You probably learned this already, and I'm going to use different color for this. If I put a point, because right now I don't have any points. I've named the number line, but I haven't really put a point. So let's put a point right here, and let's name the point. I'm going to call it point A, right? We say, it is pretty basic. What we want to say, you can see point A and see where it is, but if there's numbers associated with that point, we call that the coordinate of the point. Have you ever heard that before? Coordinate? Yeah. Okay. Yeah, it's kind of like graphing stuff, right? This is graphing, yeah. So coordinate. Ordinates. Okay. It's called the coordinate. So write it down. And that's very important. We're going to talk about that almost all year. Almost, not every day, but we'll mention this a whole bunch the rest of the year. Okay, this is the coordinate of point A. So if I ask you where the coordinate is, it means where is the location, not what point it is, because I already told you it's point A. But I want to find out where it's located. So on this number line, where is point A located? At what? At -1, exactly. So if I said, what is the coordinate of point A, what would you tell me? You would just say it's -1. It's just the location, all right, where it's located. Everybody got it? Yeah, it's pretty simple. Eventually, I think. Yeah, maybe. I can't remember if we do a lot of that. But right now, we're just going to worry about the x-axis, okay? So that's what coordinate means, all right? So if I said, what is the coordinate of point B, what would you tell me? It's 2. All right, as simple as that, okay? No big deal. I don't want to spend any more time on that. Because the name of this section is segment and angle measure, the measure of a segment. So we're going to talk about that right now, right? I tell you what, let's keep this up here so I don't have to redraw something. Let me go back to the whites. Grab that. All right. So now what we're going to do is we're going to talk about the length of a line segment. We already talked about a line segment. So let's say I'm talking about line segment AB. All right. So how do we write line segment AB? How do I write it? With a little line over top of it. Okay. No arrows, no dots, just a little line over top of it. That means line segment AB. Okay. But what we're going to do is we are going to find something called, sometimes they'll say the length of AB, find the length, I'll write that down, find the length of line segment AB, or sometimes it'll say the measure of line segment AB, okay? But they won't write it out like this, okay? There's an actual, it's kind of a symbol like we've been doing, right? We did symbols for lines, for line segments, for angles, for rays, for all that kind of stuff. Here's what's kind of weird about this. If I want to talk the length about it, I want to talk about the length of line segment AB. We could just count on this number line, couldn't we? If we start here, if I wanted to find out how long is it from, here, let me do this. Oops, sorry. Let me change this to red, and we'll turn that to that, and oh man, I'm a little wiggly. You get the idea, all right? So from here to here, if I wanted to find the length of that line right there, what would I do? I could just count, couldn't I? Yeah. So if I start here, let's count. How many? 1, 2, 3. All right, so what is the length of AB?
3.
It's 3. I could count the other way too, couldn't I? Let's do that. Let's start from B and go to A. So how many is it? 1, 2, 3. How long is it? It's 3. Now some people might say, since you're going to the left, it's what? Yeah, but when we talk about length, do we ever, if I asked you to measure something, would you say, oh, it looks like it's negative 3 meters?
No, that's impossible.
You would just say 3 meters, wouldn't you? Would you agree with that? Yeah, you'd always use the positive version of it. You'd never, it doesn't matter which direction you're going, it's still the length of it. Let's say it's in inches, all right? This is 3 inches long or whatever, okay? You make sense? We wouldn't say it's negative. So it doesn't matter if I go from left to right or right to left, it's still 3. So let me show you a couple things about this. Instead of writing that whole thing out, saying the length of or the measure of, this is how we show the measure or the length of a line segment. It's super easy because you just put AB and then you put nothing over top of it. So if the question is AB equals, and then they might have like a blank right there or a question mark, what does that mean? Just AB. If you don't have any line over top of it, if you don't have any arrows, if you don't have any symbol in front of it, if it just says AB, what does it mean, Anthony? It means the length of it, okay? It means the length of it, all right? Everybody with me? A lot of students take a long time to get this straight, but get it straight now because then it'll make it super easy. So if on a question, on the homework, or a quiz or a test, if I just said AB equals and then like a question mark or a blank or something like that, that means what? The length of it. So this is asking you to find the length of it. Now you could, if you wanted to, just draw a number line, put the numbers in here and just count. But that would be crazy. What if instead of this was -1, what if it was -73 and this was like +57, all right? Would you draw a number line and put dashes all the way to -73 and all the way to 57 and then count them? No, that would be crazy, wouldn't it? All right, so we don't do that. What do you think would be a better way? How did we get from -1 to 2, right? 3 places. How did we get a 3 out of that? Let's give somebody else a chance. Braden, you raising your hand? Oh yeah, you better be careful because I might call on you. Somebody help me. Cameron, help me out. What would be another way, instead of counting 1, 2, 3, what would be another way to find out how long that line is? Kylie, what do you think? Okay, you got it, Cameron. Good. You would subtract. Exactly right. You would subtract. So let's get rid of this red line right here. So you would subtract. Now, does it matter what order you subtracted in? Okay. Well, let's do it. Let's do it both ways. So I could go -1 minus what? 2. Or, I'm going to put an or right there. Or you could go what? 2 minus what? It's -1. Let's see what happens. Do you remember this from Algebra 1? It was just last year, -1 minus 2. I always said this. I always said add the opposite, right? You ever learn that? So what is that? It's -3. What's this right here? Again, add the opposite. It's just +3. But what did I say about the length of a segment? The length of a segment's always what? Positive. Do you remember anything when you were, I don't know, it might have been last year. You probably did this last year. That's it. You got it. If I did the absolute value of it, what does the absolute value mean? It means the answer is always going to be what? Positive. Okay? So if I put that in absolute value, that ensures, listen, that ensures that your answer is going to be positive. Why do we want a positive answer? Because we're finding the what? The length of something. And you don't get a negative length of anything. If I was going to measure something, I don't say it's negative 5 inches or negative 5 meters or whatever, okay? I just say it's 5 meters. You with me? That's why we put the absolute value in there. It ensures that my length is going to be 3. So, question is, does it make any difference what order I subtract these? It doesn't make any difference at all, does it? Okay? So, I could subtract the second one from the first, the second one from the first one or the first one from the second one. It doesn't make any difference because the only thing different is one's going to be negative, one's going to be positive, but we always take the positive version of it. With me? All right. So they could very well give you a question like this. Let's see if they give you, well, they give you a number line. Yeah, we'll just do the example that's in the book, okay? Let's change this. 24 now. Yeah. But just take notes. You don't even worry about what page you're on because I'm showing you everything you need to know. So let's do another number line. And they got a 0 right here. And then they go to 6, 7, 8, 9. Oops, let's make this smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, just fit it in there. Good. And then at negative 5, 1, 2, 3, 4, 5, right there, they call this point B. And at negative 1, they call this C, right there. And then D is at 1, 2, right there. And E is right next to it, right there. Excuse me. All right, so here's the question. Now, right after I got done saying they probably won't say find the length of, what do they do in this example if you have the book open? What do they say? It says find the length of, all right? But they won't always do that. Sometimes, like this is example, what example is this? Example 1, okay? So this is example 1. They could say this. They could just say, let's see which one they want to do. Find, did they have a point A in there? How far is that? 6, 7, 8? Yeah, I was wondering why they did A, B, C, D. Very good. Okay, so they could say this. They could say find the length of the aligned segment. Or they could just say find BD. And no line over top of it. So what does that automatically mean to you if it says just find BD? Find the length of it. Exactly right. Okay, so find the length. So let's do some math. Wow, we're 2 weeks in. This is the first time we've actually done math in a math class, isn't it? So it's kind of exciting. So let's find BD. So this was at negative 5, 6, 7, 8. This was at negative 8. This was at negative 1. This was at 2. This was at 3. All right? You can fill the rest in if you wanted to. I'm just going to do the ones with the points. So BD, I could sit there and just count, couldn't I? But again, what if they were really long numbers? I wouldn't want to do that, would I? All right, so let's do the math on it. It does not matter what order you subtract them in. You could go what? Negative 5 minus 2, or you could go what? 2, no, not minus 5. Where are you? You're at the negative 5, so it's 2 minus negative 5. So you could go 2 minus negative 5, okay, or you could go negative 5 minus 2. It's going to give you the same length. Now, one's going to be positive, one's going to be negative, but does that matter to us? No, because we're always going to take the positive version of it, okay? So what do you get? You can do this in your head. What's that? How about 7, right? Add the opposite. Okay, add the opposite. Remember that? Did your teachers ever say that? I always say that, add the opposite. Yeah, I heard that, but I like mine better, don't you? Add the opposite and add a line, change the sign. It's too much.
Because 1 minus negative 1 would be 2.
1 minus negative 1 would be negative 2. Or 1 minus negative 1 would be positive 2, correct? Right, like right here, negative 5 minus 2. I add the opposite. So watch. I turn that into add, and then I make the opposite of that. Fine? Follow that? So add the opposite. And you get what? Negative 7. But technically, when you're finding the length of something, what should these be in?
Absolute.
They should be an absolute value. All right, I'll put them there just so you know. Again, I know I'm repeating myself, but it's important. Why is it an absolute value? Because we always want to take the what version of it? The positive version of it. So either way, either way, you get a positive 7. That's the length. Length should always be positive. Everybody got that? The length should always be positive. And that's how you do it. Pretty simple. Would you agree? Yeah. I don't need to do any more. They give you 2 more examples. If you want to see, they give you like example 1A and then B and C. I think that's good enough. I think we got this covered now. Do we?
Yeah.
Okay. All right. Let's do this. Let's do some more definitions now. Let me give you this length. Now watch what I'm going to do. I'm going to copy and paste it. You know how to do that on the computer? How do you do that on the keyboard? Copy and paste. Control C, Control V. Good. Control C, Control V. And what I'm going to do, I'm just going to, just to show you, I'm just going to do that. Now, did I change the length of it at all? No. So what's true about the length of both of these? They're exactly the same. All right. So this is how we show it. If I put like a little, let's do this in a different color. If I put a little mark like this and a little mark like this, that indicates that both of those line segments, now they have a beginning and an end. I didn't put arrows on them, right? So they do have a length. You follow me? That's a line segment. So if I put a little mark, we call that a tick mark, that little dash thing right there. So if I put a little tick mark here and here, if this has 1 and this has 1, guess what's true about those 2 line segments? The length of them are what? The same or equal. They're equal to each other. Okay? But we have a word for that. Same, equal, same, doesn't make any difference. But in geometry, when you're talking about the length of something or the measure of something, we don't just say that the line segments are equal. So let's do this. Let's call this, I like the beginning of the alphabet, so we'll just do the A, B, C, D thing again. All right, I could be a little more creative, but that's okay. Yes, sir. Right here. So this is what we would not do. We would not do this. So I don't even know if I want you to write this down right here. We would not do that. Now you'd think, well, why not? That says this line segment is equal to this line segment, correct? But in geometry, they're kind of picky. They don't like saying that because we don't say the segments are equal to each other because are they the exact same segment? Is this segment the exact same segment as this? No, they're 2 different segments. They just happen to have the same what? Length. You with me on that? So we don't say the segments are equal to each other. This is what we do. We say the length of line segment AB. How do I write the length? Just AB. Just AB. Okay? And then how do I write the length of CD? Just CD. Now, I don't put an equal sign here. This might be new to you. It probably is. We put an equal sign with a little squiggly on top of it. Okay? Everybody see that?
Yep.
So that right there, it doesn't mean equals. It has a special meaning, and that meaning right there is called congruent. Now, we're going to be saying that a lot. Sam, this is your seat right here now, today, right here. Come on, quick, quick, quick. Don't say anything. Just pick up your stuff and sit right there. Thank you. All right, so this means congruent. So in geometry, when we talk about the measure of something, we're going to talk about angles here in a minute. When we talk about the measure of an angle or the measure of a line segment or the length of a line segment, then we use the word congruent. We don't say they're equal to each other, okay? We say that they're congruent to each other. You ready? So this is how we would write. If these 2 segments have little tick marks right there and they're the same length, okay? Even if they didn't have tick marks, if I said, I put a 5 here without a tick mark, this isn't really a number line, but if I put a 5 here and a 5 right here, the lengths are the same, aren't they? So we could say these segments are congruent to each other. That's the word that we're going to use in geometry more than equals, okay? We'll say congruent instead of equals each other. Everybody got that? And we're going to be using that really all year long. We're going to be saying that things are congruent to each other. So this is a super famous, common thing that we write, a symbol that we write in geometry is congruent. All right, so it's just an equal sign with a little. Did you ever see that little squiggly thing before? That always meant what when it was by itself? I don't know. Maybe it did. Well, you had two squigglies. Remember that? You had like this, like approximately, right? Roughly equal or approximately equal, right? So we just use one of those. We stick it on top of an equals, and it just means congruent. So we're talking about the length of a segment or the length of an angle or the measure of an angle or something like that. So that means congruent. All right, enough of that. Let's do an example with that. And we're going to do some more math. Isn't that exciting? That's what you came here for, right? Sure it is. All right, so let's we're going to make a line segment right here. We'll call this A. We'll call this B. And we'll call this C. All right, so this one, now we're talking algebra, aren't we? 5x, what is it, plus 10? Okay. Well, we had a definition. I'm not going to write this down, but if you look at the top 25, it says point B is between A and C if AB plus BC equals AC. So that's kind of important for what we're going to do right here. So it says B is between A and C if AB, that segment right there, or the length of that segment right there, is equal to the length of that segment right there. All right? So would you agree that the length of AB plus the length of BC equals the length of AC? Notice I didn't put any line segment symbol over top of it because we're talking about the length of it. Agreed? All right. Would you agree that this segment, if I took this segment and I took this segment, put them together and added them up, they're going to equal the whole big segment? Yeah. Make sense? That's really what that's saying. That's the definition of between. But let's actually use that to do a problem here. And so the question says, find AB. Again, they don't put a line over top of it. They don't say the length of. So it means you have to know that it means the length of. And BC, so we're finding AB and BC, those two things, if AC is 75. AC, the length of AC is 75. All right? So this is what I was talking about earlier when I said we're going to take the geometry stuff and then turn it into an algebra equation. Remember I said that earlier? So this is it. This is the first time. And this is the first of hundreds and hundreds of times that you're going to be doing that this year. All right? This is basically what geometry is all about. Taking a picture, right, that they give you. They give you some measurements, but sometimes they don't tell you exactly what it's equal to. They put some variables in there. They give you some information, and you got to answer the question about this. Braden?
So are we finding X?
Yeah, well, we have to find X first, but then what are we trying to really find? We're trying to find AB, and then we're trying to find BC. So what's the only way to find AB if we know what?
X.
If we know X. Okay, so we have to find X. But that's not our answer. We're not going to write X equals and circle it, because that's not what they're asking for, is it? What are they asking for? The length. Let's say it. Not just AB. What? The length of AB and the what? The length of BC. Okay? Everybody got that? So when you don't have a line segment over top of it, it means the length of it. All right? We're trying to find out how long is it, right? A number, right? Is it 50? Is it 25? Is it 17? Is it whatever? Okay? That's what we're trying to find. All right? So how do we set this up? Well, we kind of have a formula right here, don't we? Wouldn't you agree? All right. So AB, this segment right here, plus this segment right here, if I add them up, what do I get? I get the whole thing, right? Well, they tell us the whole thing is 75. So let's add these up. So what do I write for AB? Very good. 6x minus 1 plus BC. What's BC? 5x plus 10. Now, if I add those together, what do I get? Well, I know it. I know the whole thing. I know the whole thing. They told it to me, right? They said if AC, the length of AC is 75. So the whole thing is 75. And now, guess what I can do? Solve for X. Okay, so let's solve for X. Remember this from algebra? Yeah. Yeah, it was only few months ago, right? You did this stuff. So let's add the like terms. 6x plus 5x, 11x. Negative 1 plus 10 plus 9, right? Positive 9. And that equals what? 75. Coming back to you? What do we do to solve for x now? Yep, subtract 9 from both sides. What do we get? 66, right? 11x. How do we get rid of the 11? Right, divided by 11, divided by 11. The 11's cancel. What do we get? X equals 6. Is that my answer? Do I circle it? No, because what is the question? Find what? The length of AB and the length of BC. So what was AB? That was 6x minus 1, wasn't it? So what am I going to do with that 6? Just going to plug it in. That's right. Okay, I'm going to plug it into right here. So AB equals 6 times what? 6 minus 1, and that equals what? Right. So I'm going to write every single step so you know what I'm doing. So that's 35. So the length of AB is equal to 35. Now, do I circle that? Yeah, absolutely, because that's one of the things they ask you to solve for. There's two parts to this answer. Agreed? There's AB, and there's also BC. Now, you could find BC two different ways. Since AB is 35, the whole thing is 75, what could you do to find the rest of it? Just subtract it, right? So I could just go BC equals 75 minus 35, which is what? 40, okay? And I like to write it like this. I like to write it all nice and neat. BC equals 40, so I know exactly what I solved for. You're good to go. Or you could have just plugged it back into what BC was equal to. Do you remember what BC was equal to? Wasn't it 5x plus 10? All right, so let's take that x again, that's 6, plug it into here. Let's see if we get the same thing. We should, right? 5 times what? 6 plus 10. Do we get the same thing? Yeah, it's 40. So we get the same exact thing either way you do it. That's your first real geometry problem that we've done so far. The first of many, all right? All right. So what do you think? Are you able to take this information and then use it? This is the geometry part is the, I don't know if it's the easiest part, but it's the most important part, right? Where you're taking the picture that they give you and then you're saying, oh, what's true about this picture? Oh, this and this, they're not equal to each other, right? They never said that they were equal, but they add up to what? The whole entire thing. What was the whole entire thing? It was 75. So I take this plus this equals 75, solve for x, plug it back in to find this length, plug it back in to find this length, and that's our answer. What do you think? You good with that? Yeah, that's kind of fun, isn't it? Yeah, I think it is. As far as math goes, you know. It's not as fun as other things, but it's fun. Let's see. I'll tell you what. There's too much to finish today. I only got 4 minutes left. So we'll just stop right there. And I'll take it easy on you this weekend. I won't give you any homework. I'll give you homework on Monday, though, so don't get too excited. Okay? All righty.